All right. Hey, AP Chemistry. I wanted to help you with this next set of homework in Unit 6 with thermochemistry and thermodynamics, and this has to do with Hess's law calculations. So if you look and read in the text in the section, there are a couple of things that come up with what you could do with delta H. If I were to multiply delta H by a certain number, if I would multiply a reaction by a certain number, let's say it was 2, whatever I multiply the reaction by, I multiply my delta H by. So if I double a reaction, I double delta H. If I flip a reaction, let's say I flip it, instead of having reactants to products, I flip it and make products to reactants, I flip the sign of delta H. So like if it was positive, it becomes negative and vice versa. And then if I add a bunch of reactions together, I add all of their respective delta H's together. These ideas are important, and we're going to learn about them in class. But just to get you all knowing this in one example question, here's an example from your exercises. So it says calculate the delta H of reaction for the following reaction. So I have CaO solid plus CO2 gas yields CaCO3 solid. And I want to use the following reactions. So I'm going to have to manipulate these, meaning double, half, rearrange, and then put them together to give me this reaction, right? So I need CaO in the reactants, CO2 in the reactants, and I need CaCO3 in the products, all right? And so I like to label these reactions, like this is A, this is B, and so then I'll label this delta H as A and this delta H as B. I like to do that to just keep track, okay? And so I need to look at the equations that's given to me and find certain elements, compounds that are on the correct sides where they need to be and either fix and change the reaction or keep up, right? So for example, I need CaCO3 as a product, and the only reaction that has and there's only one of them, the only reaction that has CaCO3 as a product and only one of them is reaction A. So what I'm probably going to do is I'm going to keep reaction A. I'm going to write that as a note. I keep reaction A as is, which means I keep delta HA as is. And then now my next one, I'm going to look at this reaction. I need CaO as a reactant, but they gave me CaO as a product. So I need to probably flip this reaction. And notice how I only have one CaO here, but two CaOs here. So I'm going to need to flip this and have half as much CaO. Well, whatever I do to CaO, I have to do to every of the other reactants and products in the equation. So there's only one product in this equation that I'm going to flip. I'm going to half my CaO, which means I'll half my Ca, and I'll half my O2. Hess's law calculations is one of the only weird type of calculations in which we could have these half or fractional stoichiometric coefficients. They eventually will go away. So again, with Hess's law, I need to manipulate these equations and do something to them. I either rearrange them, flip them, multiply them, and then eventually add them all together to get them to look like this equation. Remember, my desired equation is CaO plus CO2 as reactants and then CaCO3 as products. So we're keeping A as itself because CaCO3 is a product. And it's looking like if I want CaO as a reactant, I'm going to have to flip this equation. So I'm going to flip reaction B, and then I only want half of the CaOs that are here. There's only one CaO in my desired reaction, and I've got two in the reaction given to me. So I'm probably going to half the reaction of B. Now, if I flip the reaction, I'm going to take delta HB. Delta H, I'm going to make it the negative, or I'm going to flip the sign. So delta HB is already negative. So I'm going to say I'm going to flip the sign or make it negative. And then if I want to half the reaction, I got to half delta HB. So I'm flipping it, so I'm negating it. You could also say flipping is the same thing as just negating the sign. Even if you had negative, it becomes positive. If you have positive, it becomes negative. So I negative or flip the sign, and then I multiply by a half because I'm halving the reaction. So let's try and put what I said here together. So I'm going to keep reaction A as is. Ca solid plus CO2 gas plus half O2 gas yields CaCO3 solid, and I'm keeping its delta H of negative 812.8 kilojoules. And then and here's A. And then what I said is I'm going to flip B, and then I'm going to half it, right? So if I half this whole thing, right, and eventually I'll flip it, I'm dividing everything by 2. We're also going to be dividing that by 2, and then I'm going to flip it. So I'm going to have my new B be CaO solid. All right, and now I could go straight to products. Half of the 2 is 1 Ca solid plus 1/2 O2 gas. And this delta HB is going to be times negative 1/2. All right, I didn't do that math yet. I'm basically going to take this 1269.8, negate it, and divide it by 2. Okay? I kind of did this on the side somewhere, but we'll show the answer. So now I have almost the beginnings of what this reaction will eventually look like. If I add these two together, and remember in kinetics when we had multiple steps that we could add together, if I add these two reactants together, do I get my desired reaction? This is like a nice check. So I put all of the reactants together. I have Ca solid plus CO2 gas plus 1/2 O2 gas plus CaO solid. Those are all of the reactants left side. Let's put all the products together. CaCO3 solid plus Ca solid plus 1/2 O2 gas. And this is almost looking like my equation. Remember when we did the kinetic steps and we had step 1, step 2, all of the steps need to add up to the desired reaction. And if there's anything the same on the left side and right side, I could cancel them out. Well, I have Ca and Ca on both sides, canceling those out. I have 1/2 O2 and 1/2 O2 on both sides, canceling them out. So I'm going to have CO2 gas plus CaO solid yields CaCO3 solid, which is actually my desired reaction. Just have these two switch, but it doesn't matter. Right? So CaO solid, CO2 gas, CaCO3 solid. Boom. So if I keep reaction A and I flip and half B and I add them together, I'll get my desired reaction. Now, whatever I did to the reactions, I have to do to my delta H's. So it's looking like my delta H's, I'm going to just move this down a little bit. If I want my delta H of reaction, it's going to be delta HA, because I just kept it, plus 1/2 the negative of delta HB. And B was negative 1269.8. So now let's do that again. Delta HA is negative 812.8 kilojoules per mole of reaction plus negative 1/2 delta HB, which delta HB originally was negative 1269.8 kilojoules per mole. I'm going to do the math of this on the side, but basically I'm taking negative 1/2 and multiplying it times negative 1269.8. Now remember, why am I doing negative 1/2? I'm going to move down a little bit more. Why am I doing negative 1/2? Well, in order for me to get CaO as a reactant, I have to flip the second equation, which means if I'm flipping an equation, I'm going to do the negative, or I'm going to negate or do the opposite sign of the delta H that I have originally. And then I only want half as much CaO because I have 1 in my desired reactant but I got 2 in this given reaction, so I want to have half as much. If this said 4 CaO, and this is only 1, then I would divide everything by 4. So whatever I do to the reactant to give me my desired reactant, I do to the entire equation. So I have to divide everything by a half, and so now I'm dividing that by half. And just so you can see the number that I get, negative 1 divided by 2 times negative 1269.8. And this number becomes positive 634.9 kilojoules per mole reaction. And then what I do is I take this negative number and I add it to that one. Okay? Delta HA was that, delta HB was that. And so now all I got to do is put these together. I got negative 812.8 plus 634.9. And I get my answer, or my delta H of the reaction, which is negative 177.9. Negative 177.9 kilojoules per mole of reaction. Okay, so this is how you do a Hess's law calculations. On the AP exam, they might not ask you to do all of this, but what's very important is the type of calculations that come up with flipping a reaction or doubling a reaction or adding reactions together. So if you need to rewatch this video so you can see how I do those steps, make sure you do that. There will be more example videos in the future and that are already in the Google Classroom.